Hello, in this class of GSM, our topic is GSM signaling. So, today we are going to discuss GSM entities, and signaling architecture. So, before moving to signaling architecture, let's understand what is signaling. Signaling is my control signals, and the flow of control signal is known as signaling process. Now, what are control signals? I want that my system and this system should be organized. And in order to make a system organized, I want to add some protocols in it. Like if I want to make my organization systematically, I want to design my organization systematically, so I require to add some rules and regulation to the corporation. Like this GSM is a complete system and I want that my GSM system runs appropriately, so I want to add some protocols in GSM system. That means to regulate, I require to add some rules and regulations. So these protocols, that means how my system will run, how my MSC will locate users, how control signals will flow. So that means we have two types of signals. One I name it as control and another one as traffic. Traffic signals are the signals which carry my data bits, but control signals are the signals that carry my data bits, but those who used for controlling the system. So I require to add these protocols to my system so that my GSM global system for mobile communication work properly. So that means this is my signaling part. So today we are going to discuss that how signaling system, that means what are the protocols in which entities, what are the protocols are organized. So now for computer networks, we have two types of system, as we have always two types of system. One is that closed systems and another one as open system. Closed system is basically a system in which we don't have compatibility between two different systems. For example, in closed system, if this is a laptop of HP and this is a laptop of Dell, so these laptops are not compatible with one another. Like Apple, this form its closed system. Like we can connect Apple to Apple, but we cannot connect Apple with Bluetooth to other devices because this form a closed system. Whereas for open system, we can openly connect any devices with one another, except those who are closed. So in order to make these closed system open, we require a model, and that is OSI model, where OSI is open system interconnection. That's why it is named as open system interconnection model. Like in GSM, if we require to call from Airtel to Airtel, Reliance to Reliance, then means Airtel is a closed system, Reliance. But we require to call from Airtel to Reliance, Airtel to Vodafone, any of the operator. So that means we require to form some model that like OSI. So in GSM, we also have a protocol model. And this protocol model, like OSI has 7 layers, but this protocol model of GSM has only 3 layers. So this is 3-layered model. GSM systems are following 3-layered model starting from the very first, that means physical, then we have data link layer, and third one as network. So we have in 3-layered model, that means GSM is following 3-layer model structure in which we have a physical layer, data link layer and network layer, only 3 layers. It's not using the 7-layer model structure of OSI but only 3-layer structure because it requires for communication only 3 layers. Session, presentation, application, which is for encryption and application part, are not used in this. We are using only 3-layer structure, starting with the very first as physical, data link and network layer. So if I compare that physical layer, so what is physical layer? This physical layer does not mean that it is any physical connection. It is just a media. So like this is my mobile station, and this mobile station requires to attach to BTS. So we require a media. If this is my, I'm connected with the help of air. So this layer will be my physical layer through which I am connected. If I compare that, this is BSC and I am connected with this with the line or a wire. So this media wire is also a physical layer. So I can say that if I compare with wired and wireless, so my physical layer could be wired or it could be wireless, both. So that means who is providing a media to communicate? Our physical layer is providing a media for communication. Now we have next layer as data link layer. Now this data link layer is used for error detection and corrections. So which layer is used for detecting error and correcting the errors? So we have a data link layer for error detection purposes. And then we have network layer, and this network layer is used for communication. So that means each and every layer, layer 1, layer 2, layer 3, we can see the messages flowing in each and every layer with the help of a software. We can see the layer 3 message, layer 2 analysis. So like this we have analysis of layers. Now let's move to the signaling architecture. This being the protocol stack at the mobile station end. I will write layers here. This one as physical, this one as data layer, layer 1, layer 2, layer 3, network. So this is the protocol signaling architecture at mobile station end. Now let's move to the BTS end. LAPDm, RR. This being the architecture towards the BTS end. Now this one at BSc end. BTSM. This is RR. I will divide like this. BSSAP. Now let's move towards the MSc end. This being at towards MSc end. SCCP. Then we have BSSAP. After that DTAP. DTAP. Then we have CM, and we have MM. Now remember that similar to similar connection is there. Radio to radio, 64 to 64, 64 to 64. LAPDm to LAPDm, LAPD to LAPD, SCCP to PSSCP, BTSM, RR to RR, and this RR is joined to this. MM is joined to MM, and CM is joined to CM. So this being the protocol structure or the signaling architecture followed in GSM system. Now we require to follow that we have only 3 layers. So this being 1, 2, and whole of this is 3. Like this one is my first layer, this one is my second layer, and this one as third layer. Layer 1, layer 2, this all is layer 3. Now layer 1, layer 2, and this all, that means till this is my layer 3. That means whether mobile station or BTS, BSc or even MSc, each and every unit is following 3 layer structure, because it is that we require in GSM system, we always require to follow only 3 layer system. Now if I talk about this interface, this is my air interface. From BTS to BSc, I have a BIS interface, and from BSc to MSc, I have a interface. These are the interfaces defined. Or this air is also known as UM interface. Now, these protocols, that means mobile station has access to radio part, LAPDm, and all these protocols. Whereas this protocol, sometimes we have LAPD and BTSM. These are the protocols which is not required by mobile station. So these protocols are required by our BTS system. Similarly, some new like SCCP and BSSAP is required for connection between BSc and MSc, and they are recognizing each other. The connection means that they are recognizing each other, with the help of which we can communicate. Like LAPDm, LAPDm, LAPD, LAPD. So we are communicating to one another if my protocols are recognizing from each other. So like this we can contact radio part 64, 64 and 64. Now coming about the names of these protocols, and after that we will discuss the functions of these protocols. Now first is CM, which is connection management. We have MM, which is mobility management. Now we have RR, this is radio resource. After that we have LAPDm, this is link access protocol for link access protocol for D channel, data link channel, where M is for mobile. That's why required by mobile station and connectivity. Link access protocol or procedure both. Now this we have link access LAPD as link access procedure. Link access procedure for D channel. Now next, that means after this we have BTSM. Now BTSM stands for BTS management. BTS management part, or we can write BTS management part M. Okay, now BTSM we have BSSAP, which is again BSS base station subsystem application part. After that we have DTAP. DTAP is direct transfer application part. After we have application part, the DTAP. Next we have MAP. This MAP is mobile application part. SCCP. This one has signaling, connection, control part. After SCCP we have TCAP. This TCAP is transaction capabilities application part. Application TCAP as transaction capabilities application part. This I have not mentioned in that protocol structure, but these are the protocol existing. We will discuss these also. And we have ISAP also. ISP is ISDN user part. These are the part of the SS7. So these are the full forms of various protocols in our signaling architecture. Now, if I draw, I have not explained the functions of each and every protocol. We will discuss these functions in our next class. So today I am just organizing so that it will be easy to recognize the protocols. So as I have one entity, like this is my mobile station. So after that we require with BTS. So this one as BTS. Now after this we have BSC, mobile station, BTS, BSC, then we have MSC. So okay, MSC. So I will write that this is my MSC oblique BLR. So if MSC oblique BLR, after that I require HLR and GMSC. So okay, this is the database and this is by HLR and this one as my GMSC. So these are the databases that I have attached. Now I will organize the protocols. Now a very first protocol, that means which is used for transmission, is for this much part. So transmission part has MS, BTS, BSC and MSC VLR. Now coming to radio resource protocol, so this RR protocol is used by all. That means by mobile station BTS, BSC and MSC. Now we have MM protocol. Mobility management protocol is required for HLR also. So I am mentioning like this. I have not given mobility management to these entities because mobility management is related to HLR and VLR. But if I go to CM, that means connection management, then I require with GMSC also. That means gateway MSC. Also, I require connection to the gateway MSC also. So today we have discussed all the signaling architecture and its representation. The overview of each and every protocol and the working of protocols with their proper call flow, which we will discuss in our next class. So this is all for today. Thank you so much.